Math 2414 Power Series Video 1 Definitions. This will be a relatively short video because I'm just going to give you, well, as the title implies, some definitions. And then the rest of the videos will mostly be examples along with one key and critical theorem. So let's start what we mean by power series. A power series is, first off, it's a series, and it's a series of the form the sum n equals 0 to infinity, and these almost always start at 0, of some coefficient, which we'll call Cn, times the power of x, x to the n. And we actually define this to be a function, f of x. And the coefficients are typically functions of the position. So for example, if n equals 1, you do something to it to get the first coefficient, or n equals 0. If n equals 1, you do something to it to get the next coefficient, and then n equals 2, you do something to 2 to get the next coefficient, and so on and so forth. But we can talk about a more general power series, a power series centered at some number, x equals a. And it looks like the same definition, but the only difference is instead of saying x to a power, you say x minus a to a power. And so in that light, you can almost think of the first definition as a power series centered at x equals 0, because you can write the sum as the sum n equals 0 to infinity of whatever the coefficient is times x minus 0 to the nth power. So we're going to talk a little more generically about power series being centered at some real number a, and x minus a will be the part that's raised to the nth power inside of the sum. Now, since these power series, since these functions are defined as an infinite series, there is an issue of whether or not the function will converge, or rather the series will converge. But since we're putting in different values for x, we can always ask the question, will the series converge or diverge for a particular x value? So as a consequence of that, the domain of these functions is defined to be the set of all real numbers such that the series converges. And it's worth noting that at a power series, it will always converge at its center. In other words, if I put the center into the function, well, let's go to the next page to do this. If I put the center into the function, so for example, let's say our function is f of x equals the sum n equals 0 to infinity of some coefficient as a function of the position times x minus a to the n. And let's make that a little bit better, maybe. If we were to expand this by letting n start at 0, then we would get c0 times x minus a to the 0 plus c1 times x minus a to the first plus c2 times x minus a squared. And this first term, or the first parentheses raised to the 0 power, will almost always equal 1, because remember, anything to the 0 power is equal to 1. There is one exception. 0 to the 0 power is technically indeterminate, but for the sake of power series, we allow 0 to the 0 power to equal 1. That way we can define this function for any value of x, even a, because if we did put in a right now, then technically we would get 0 to the 0 right there, and that would be undefined. But for the sake of consistency and simplicity, we're going to allow 0 to the 0 to equal 1. And so in that case, we can rewrite this expanded version of the series as just c0 plus c1 times x minus a plus c2 times x minus a in parentheses squared, and so on and so forth. So this way we don't have to say, well, that's what the series equals except when x equals a. If we just let 0 to the 0 power be equal to 1 in this instance, then we can say that our function, when it's expanded, looks like this. And so as a consequence, when we put in a, we get C0 plus C1 times a minus a to the first plus C2 times a minus a to the second. And everything zeroes out except for the first term. So it's worth pointing out, and I'll say it once again, that every power series will converge at its center, meaning that if we have a function defined like this, then we will always get convergence when x equals a, because the result of putting in x equals a will just give us the first term right there. All right, so in the next video, we'll take a look at some examples. In fact, in the next videos, we'll take a look at some examples. I plan on doing one example per video.